We have traditionally viewed the colossal monuments of the Old Kingdom, structures like the Step Pyramid of Djoser, or the massive pyramids at Giza, as isolated architectural projects. The common assumption is that each pharaoh commissioned a standalone tomb designed and built without reference to the others. That perspective changes when we measure these structures using the royal cubit, the exact unit used by the original builders. This chart displays the distinct architectural profiles of 7 major Old Kingdom pyramids. When aligned and measured in cubits, these structures reveal a hidden underlying architecture, suggesting they are part of a single continuous dataset. The numeric progression of their bases is highly specific. Moving from left to right, we see the Kaaba layer pyramid at 160 cubits, the Red Pyramid's half base at 210, Medum at 275, and the Bent Pyramid at 360, eventually culminating in Djedefre's 809-cubit perimeter. This sequence of overlapping data indicates that these monuments were not the result of trial and error engineering. Instead, they appear to be physical iterations of a unified master blueprint. This diagram illustrates the mathematical operator that acts as the engine for this entire sequence. Every major leap in scale between these monuments is generated by a single repeating multiplier, 1.309. 1.309 is an irrational constant, roughly equivalent to the golden ratio squared, then divided by 2. It is a precise and demanding mathematical requirement. Achieving such flawless scaling across generations would normally require advanced symbolic algebra and precise decimal calculations. But these tools did not exist during the Old Kingdom. This creates a paradox. We are left to wonder if the Egyptians possessed a lost form of advanced mathematics, or if there is a radically simpler physical explanation to be found in the sand. By setting aside modern algebraic assumptions, we find that the solution lies in the ancient reality of simple field geometry. This method relies on repeatable physical actions and spatial logic rather than written symbols. The actual surveyor's toolkit was remarkably sparse. As shown here, it required only a flat plane, a wooden peg, and a length of taut rope. The process begins by establishing a baseline geometry, a perfect square with a side length of S marked out on the ground. In this mixed phase, the surveyors bisect the base of that square. By folding their measuring rope in half, they locate the exact mathematical center, dividing the base into 2 equal parts labeled A over 2. Using that midpoint as a fixed anchor, they stretch a radius rope labeled L diagonally to the far top corner of the square. Finally, they swing that radius rope down until it meets the baseline. This physical extension creates a new, longer length based on the original square. This sequence automatically produces the 1.309 scaling factor. By simply bisecting a square and swinging a rope, the builders achieved the exact mathematical constant we observe across the monuments. The Bent Pyramid provides physical proof that this geometric method was consciously implemented by ancient architects. This diagram shows the pyramid's 2 distinct modules, an upper base of 236 cubits and a lower base of 360 cubits. Their ratio, 236 to 360, reverses to yield the 1.309 constant. This confirms the multiplier was a foundational design parameter, not a construction error. This slide confirms our conclusion. The entire proportional chain was a deliberate design choice, driven by the repeatable geometric scaling of the bisected square. Now that we understand how the builders constructed this spatial machine, we have to ask what it was designed to measure. Once the 1.309 multiplier established a primary dimension, like the 210-cubit half base, architects used simple doubling to scale other components. As shown here, 210 cubits doubles to a 420-cubit full base, then an 840-cubit doubled base, before reaching a terminal value of 1680. That terminal number, 1680, connects the physical structure of the pyramid to its primary ritual function, the eternal resurrection of the pharaoh. In Egyptian theology, the sacred mummification ritual lasted exactly 70 days. Those 70 days translate precisely to 1680 hours. This 1680 temporal motif is woven directly into the physical layout of the monuments, turning architecture into a physical record of the resurrection timeline. Evidence of this correlation is found across the Old Kingdom. The step pyramid of Djoser contains exactly 1,680 niches in its wall, and the red pyramid, shown here, was built with an exact perimeter of 1,680 cubits. The ancient pyramid texts carved into these walls confirm that this obsession with time tracking was explicitly theological, ensuring the king's journey through the afterlife was perfectly timed. Through the elegant application of rope and peg geometry, the pyramids functioned as unified spatio-temporal clocks, permanently timing the pharaoh's resurrection and securing his place among the stars. The footprints of Khufu and Khafre dominate the Giza plateau. In standard archaeological records, these dimensions are viewed as the result of a builder's ambition, a massive but ultimately arbitrary scale. Yet when measured in royal cubits, the perimeters of these two bases align with a specific geographic logic. This logic centers on the number 43,200. To a modern observer, this scalar is recognizable as exactly half of the 86,400 seconds that comprise a single day. Scholars often categorize this as a coincidence because the Egyptians did not use minutes or seconds. However, this specific proportion is reflected in the earlier architecture of the Third Dynasty, where the first large-scale pyramids were designed at exactly half the size of Khufu. Applying this 43,200 scalar to the Great Pyramid yields a specific result. Khufu's base perimeter is 1,760 royal cubits. When multiplied, that total matches the Earth's equatorial circumference to within about 0.5%. Khafre, standing directly beside it, has a base perimeter of 1,644 royal cubits. Multiplied by the same scalar, the result matches the Earth's circumference at 23.4 degrees latitude, the exact limit where the sun reaches its highest point in the sky each year. This alignment suggests the builders were not mapping the Earth through modern cartography, but were instead translating the movement of the sun directly into their blueprints. The foundational tool for this measurement was the Gnomon. By tracking the shadow cast by a simple vertical stick on a flat plane, surveyors could map the sun's path and determine the precise solar limits of their location. This tracking defined the Egyptian temporal hour. Rather than using 60 fixed minutes, they divided every period of daylight into 12 segments. Because the sun stays up longer in the summer, these segments were dynamic, stretching in the heat and shrinking in the winter. The behavior of these temporal hours depends entirely on geography. At the equator, where the sun's path is constant, these hours remain the same length year-round. As you move toward 23.4 degrees latitude, the variation in daylight increases. The length of a temporal hour shifts by a specific mathematical proportion compared to the equatorial baseline. To an ancient surveyor, tracking these shifting shadows provided a physical method for determining their geographic latitude without the need for complex instruments. This brings us back to the ratio between the two pyramids, 1,760 cubits for Khufu and 1,644 for Khafre. This architectural ratio mirrors the physical change in solar time. The difference in size between these two pyramids matches the mathematical proportion by which the length of a daylight hour shifts between the equator and the Tropic of Cancer. This indicates that the builders did not rely on abstract algebra to calculate the size of the planet. Instead, they used physical measuring rods to record the seasonal rhythms of solar shadows. Khufu and Khafre are footprints of time, representing a successful attempt to scale the cycles of the sun into physical stone. The pyramid texts frame these structures as resurrection engines rather than static tombs. The precision was a functional requirement for the king's afterlife. In Egyptian theology, the pharaoh became an Akh, an eternal spirit. To navigate the sky, the king was believed to travel alongside the sun god, Ra. Success in this journey required a map of the sun's physical limits. The encoding of the solstice extremes at 23.4 degrees latitude provided the architectural coordinates the pharaoh needed to navigate the sky. Achieving this level of accuracy required no advanced technology, only the mastery of ropes, shadows, and field geometry. The architecture of the Giza plateau stands as a permanent record of time cycles, built as a map to guide the pharaoh toward eternity.